So hello and welcome to the video on comparing numbers in standard form. So we're going to kickstart this with a few examples, and we've got some questions and then some slightly harder examples later on. So the first example says to compare 8.43 times 10 to the 6 and 2.38 times 10 to the 8. So when we're comparing numbers in standard form, the first thing we really have to look at is, firstly, are the numbers in standard form? So, is it a number between 1 and 9? We can see here that the numbers are, so that's perfectly fine. And then the second consideration we really need to make is what power of 10 do we have? So, for this, it's 10 to the 6. And this is 10 to the 8. So what does 10 to the 6 and 10 to the 8 mean? Well, 10 to the 6 means that we've got 1, 0, 0, 0, 0, 0, 0. So that means we're timesing by a million. And 10 to the 8 means that we have 1 times 0, 0, 0, 0, 0, 0, and then 2 more zeros. Felt like I was saying 0 forever there. So we can see that the number that we're multiplying by for this 2.38 figure here, this has far more zeros than the 10 to the 6, which must mean that the 2.38 times 10 to the 8 is the bigger number. So what we would say here is that 2.38 times 10 to the 8 is larger. So use the correct symbol, larger than 8.43 times 10 to the 6. So this is the second example. So here we have compare 3.2 times 10 to the minus 10 and 1.2 times 10 to the minus 9. So in the previous example we were looking for the highest and largest power of 10. So the highest and largest power of 10. Now, this one could be slightly misleading in the fact that we have 10 to the minus 10. So you might think, well, oh, 10 to the minus 10 is the largest power of 10. That is not the case. It would be 10 to the minus 9. Because if we think about it, minus 9 is a bigger number than minus 10. Yeah, so therefore, 1.2 times 10 to the minus 9 is greater than 3.2 times 10 to the minus 10. Our third example here highlights what decision you have to make if the powers of 10 are the same. So here we have 5.65 times 10 to the power of 5 and 5.56 times 10 to the power of 5. So, as I said, we can see here that the powers of 10 are the same. So then we just need to look at, well, which number is bigger? So we can see that 5.65 is bigger than 5.56. So we just write 5.65 times 10 to the 5 is greater than 5.56 times 10 to the 5. Okay, so after having looked through a few examples, now we've got some questions that we can work through. So here we're just looking for a greater or less than sign. to just pick which number is bigger. So 2.1 times 10 to the 6, and is that larger than 8.9 times 10 to the 5? Well, we consider the powers of 10. 10 to the 6 is 10 times larger than 10 to the 5, so the 2.1 times 10 to the 6 is the larger number. 8.1 times 10 to the 6, is that bigger or smaller than 8.9 times 10 to the 5? Well, again, the power of 10 to the 6 is larger, so it's greater. 3.3 times 10 to the 2, is that smaller or bigger than 3.1 times 10 to the 3? Well, 10 to the 3 is a larger power of 10. So 3.1 times 10 to the 3 is larger. So for 1.61 times 10 to the 3 and 1.89 times 10 to the 2, well, again, both the numbers are in standard form, so we just look at the powers of 10. 10 cubed is larger than 10 squared. Question 5, 2.1 times 10 to the 4 and 3.8 times 10 to the 6. 10 to the 6 is the larger power of 10. Question 6, 7.2 times 10 to the minus 4 and 5.7 times 10 to the minus 8. Well, for minus numbers, as established in the example earlier, we want to look for the less negative number. So the number that isn't as negative. Minus 8 is more negative than minus 4. So 7.2 times 10 to the minus 4 is the larger number. Similarly for number 7, 9.5 times 10 to the minus 2 and 1.89 times 10 to the minus 1. Minus 1 is less negative. Question 8, 4.7 times 10 to the minus 3 and 1.25 times 10 to the minus 1. Again, the minus 1 is the less negative number, so 1.25 times 10 to the minus 1 is the bigger number. Okay, so question 9 and 10 require a little bit more working out because they aren't already in standard form, so we've got to put them in standard form. So for question 9, we've got 0 point, and it's 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros after the decimal place, and it's 2, 1, 2. So we put that into standard form. So move the decimal point once, twice, 3 times, 4 times, 5 times, 6 times. So 2.12 times 10 to the minus 6. So then, is 2.12 times 10 to the minus 6 smaller or larger than 2.12 times 10 to the minus 5? Minus 5 is the less negative number, so 2.12 times 10 to the minus 5 is the bigger number. And similarly for this last example, we've got 3.4 times 10 to the 5, and then this hideous looking number. So again, we've got to put this into standard form. So it's 34, and then there was 1, 2, 3, 4, 5, 6 zeros. That's 3, and that's 6 zeros. So putting this into standard form. So the decimal point will be here. So 1, 2, 3, 4, 5, 6, 7. So it becomes 3.4 times 10 to the 7. Is 3.4 times 10 to the 7 bigger than 3.4 times 10 to the 5? Sorry, it is, because 10 to the 7 is larger than 10 to the 5. So the last part of this video is comparing numbers that are almost in standard form. So as we can see, we've got 574 times 10 to the 5 and 5,470 times 10 to the power of 2, or 10 squared. So these numbers are very, very nearly in standard form. They look like numbers in standard form because we've got 10 times them by 10 to the power of something. But as we can see, the numbers, the 574 and the 5,470 part, aren't numbers between 1 and 9. So what does that mean? It means that we've got to put the numbers into the correct standard form, and then we can get an eye on how we're going to compare them. So 574, I'm going to do each number separately. So 574 times 10 to the 5. So what I'm going to do is ignore the times 10 to the 5 part. I'm just going to pretend I've got 474. So I'm going to put that number into standard form. So it's, the decimal point would be here. So we move it once and then twice. So it would be 5.74 times 10 squared. But then we didn't do anything with the 10 to the 5, so that just drops down onto our next line of working. And when we have the same base and we're multiplying those bases together, we can add the powers from the rule of indices, or one of the rules of indices. So this becomes 5.74 times 10 to the 7. That now looks like a number in proper standard form, if you like. So we're fine with that. So then all we have to do is consider the 5,470, and that's times 10 to the power of 2. So again, I'm going to ignore the 10 squared part. I'm just going to deal with the 5,470. So the decimal place here will move once, twice, 3 times. So it'll be 5.47 times 10 cubed. And then I didn't do anything with the times 10 squared, so I'll just drop that down onto the next line of working. Again, 10 cubed times 10 squared, well, they're of the same base, which is 10, so we can just add the powers. So it's 5.47 times 10 to the 5, which again came from adding the powers because the numbers are of the same base. So then we just compare the numbers as we did before. We go through our little checklist. Are the numbers both in standard form? They are now. And which number has the bigger power? 10 to the 7. So we conclude that 5.74 times 10 to the 7 is larger than 5.47 times 10 to the 5. Okay, so this will be the final example of this video and last question. So we've got 655 times 10 to the minus 3 and 5,480 times 10 to the minus 6. So we're going to do exactly as we did before in the last question. So we've got 655. We're just going to worry about the 655 times 10 to the minus 3 for the time being. And we want to put this number into standard form. So currently our decimal point lies here, so we move it once and twice. So moving the decimal point to the left, which means that we will get 6.55 times 10 to the power of 2. Again, we never did anything with the 10 to the minus 3, so that will just drop down. And again, from the previous example, we know that we've got the same base, which is 10, so we can add the powers. So it'd be 6.55, and we've got 2 plus minus 3. Well, that is just 2 minus 3, so it'll be 10 to the minus 1. And we're now happy that that number is in standard form. So all then we need to do is convert our other number into standard form, and then we can compare them. We've got 5,480 times 10 to the minus 6. And again, we'll do the same thing that we did. We'll put the 5,480 into standard form, and then we'll worry about the powers later. So putting this into standard form, we move the decimal point 1, 2, 3 times. So that's 3 times to the left, so we get 5.48 times 10 to the 3, because we move that decimal point once, twice, 3 times. And we didn't do anything with the times 10 to the minus 6, so that will just drop down. So times 10 to the minus 6. And again, we know that when we've got numbers of the same base, we can just add the powers when we're multiplying them together. So we've got 10 cubed times 10 to the minus 6. So that is just 3 plus minus 6. Well, 3 plus minus 6 is just 3 minus 6. So we're left with 10 to the minus 3. So now it is no different from any example that we did previously in the video, because the numbers are both in standard form, so that's perfectly fine. And then all we need to consider is which power of 10 is larger. So minus 1 is larger than minus 3, because minus 1 is less negative than minus 3. Like that.